The sun has always been a source of warmth, comfort, and light. But we're discovering a new and frightening side to our star. A kind of solar rage peaks every 11 years. And sometimes, Earth is in the line of fire.
It's 1 billion tons of matter traveling at 1,000,000 miles an hour.
A solar blast could send us scrambling. Without warning, navigation systems could be disrupted, blinding jets in the sky. Phone connections around the world could go dead, leaving us stranded during emergencies. And within minutes of impact, a power blackout could leave millions of people in the dark. In a land of ice and snow, the sun sets life into motion, bringing precious warmth and light to our planet. Without the sun's energy, life would quickly vanish from the surface of the Earth. When the Arctic sun finally sets, it may not rise again for months. A dark chill is cast over the land. Here, the Inuit people have long taken their cues from nature to survive the harsh winter months. They use the northern lights to guide their way in the darkest times of year. They believe the sky forms a dome above their heads, and their ancestors dwell on the other side. The shimmering lights are heavenly torches held by spirits as they play in the skies above. They are beacons to guide the souls of the newly dead. Perhaps there is a wisdom in the stories of these old men. Perhaps our lives are more profoundly tied to the heavens than we know. We understand now, as we voyage into space, that the ribbons of light are caused by the sun. Today, scientists are taking a closer look at our neighborhood star, and its disposition is not altogether sunny. An erratic sphere of superheated gas, the sun is 15 million degrees hot at its core. Powered by nuclear fusion, our raging sun is an ongoing H-bomb, equivalent to megatons going off every second. And yet, it is somehow easy to take for granted.
People go out in the street, they look up and they think, big ball of fire in the sky. It doesn't change, very constant, always there. But when you look at it, you realize it's just a big mass of gas that's forever in turmoil, forever churning up, always spewing out things into the interplanetary medium. It's just a great thing to study. You never know what's going to happen tomorrow with it.
What we want to do is understand this stuff. I mean, we don't just looking at it because it's pretty. We want to understand what's going on, and we want to be able to predict things because it does impact us on Earth.
The sun has the potential of disrupting us in ways that we haven't understood before, just because we are a more wired, connected, interconnected world. A disruption could potentially, in certain places and in certain technologies, be rather serious.
Our star is the only star that directly affects our planet. And yet the sun remains an elusive and distant frontier, beckoning us to take a closer look.
One thing I like about observing the sun is that it's this tangible disk. You can see it, you can feel it. Unlike other stars that present themselves only as a tiny spot, the sun, although it is a star, is up close to us. You can see its personalities, if you will, and you can plot these, unlike most other stars.
Larry Webster has been studying our daylight star for 22 years. His work carries on a long scientific tradition of recording the faces of our ever-changing sun. High above the Los Angeles basin, Mount Wilson Solar Observatory is an ideal place for watching the sun. At the 150-foot solar tower, a century-old ritual is about to take place.
Okay, what I'm doing is adjusting the coelostat so that the reflection of the sun comes off the first mirror into the second mirror, and then that redirects it down to the objective lens. And it's actually the lens that forms the image of the sun in the room below.
The ancients called the sun a most pure and lucid body, but Larry Webster sees instead a surface covered with blemishes, sunspots. He begins each fair day by sketching the face of the sun. No two portraits are alike.
To the casual observer on the street, the sun might be just this unchanging hot disk in the sky. But to the astronomer, it's a disk that has a lot of features on it that can be observed. Like today we have these sunspots, and to the solar astronomer, that's a very strong magnetic field right there.
The sun's magnetic fields are spawned by invisible forces beneath its surface. Where the field is most intense, sunspots tend to form. Often several times larger than Earth, these blemishes can last as long as 4 months.
Sunspots are the physical manifestation of magnetic fields on the sun. They're cooler by about 1,000 degrees, and so when you see a sunspot, it's darker against the surrounding photosphere because of that. And then the magnetic fields might come out, loop around, and come back into a adjoining spot or next to it.
The sun's magnetic forces are constantly changing. Its field lines twist and knot with the sun's rotation. Over an 11-year cycle, these magnetic lines become more and more tangled, breaking the surface to create sunspots. At solar max, the peak of the sunspot cycle, the sun is coiled and ready to strike.
Professionally, I study the sun to carry on the tradition of solar observing. We don't know everything there is to know about the sun. Any changes in the sun's output can affect the Earth dramatically. And so we continue with the record keeping of observing that's been going on really since the 2nd century BC with the ancient Chinese records.
The grand astronomers of the Chinese imperial court observed the sun with their naked eyes each dusk and dawn. The first to record sunspots, they noted crows, pears, and goose eggs on the face of the sun. These apparitions foretold the death of emperors and other calamities. It was not until Galileo aimed his telescope at the sun that sunspots became an object of scientific study. Galileo confirmed that these blemishes lay on the surface of the sun, where they waxed and waned and were carried around by the sun's rotation. His claims shocked the world. He had suggested that the sun was less than perfect.
And we do these drawings in the exact same way, in many respects, as Galileo did in 1610. So we're carrying on that tradition, but we're adding to the scientific data over all these centuries involving the activity cycle of the sun. Now, sunspots can appear as anything from a single speck on the sun to a large, well-developed area like you see here. In fact, it can be several times the diameter of the Earth. If I put this BB that represents the Earth over that sunspot, you can see the size relationship there.
The sun so dominates our planet in size and power that even the smallest change might be felt on Earth.
The sun's output certainly will affect the Earth. A change of just 1% on the sun, extended change, could change the Earth dramatically in a way that maybe the Earth's climate could not recover from.
The sun is suspected to have shaken our climate in the past. A long cold spell began in the 1600s. Ice skaters raced on Dutch canals that had never been frozen and haven't been since. From 1645 to 1715, astronomers happened to note an absence of sunspots over the course of 6 solar cycles. Was this solar anomaly somehow the cause of a miniature ice age? Today, we know that the sun's brightness varies over its 11-year sunspot cycle. When spots are at a minimum, the sun is dimmer by 1 part in 1,000. At solar max, a brighter sun seems likely to warm our planet. Yet Earth's reaction is so complex, we still don't fully understand it. Ironically, some hope to find the answer written in ice. A Himalayan expedition set out in 1997, and during temperatures of 15 below Fahrenheit, 45 people made the trek. Documenting their climb with a video notebook, they lugged 6 tons of equipment, even a refrigerator, to a glacier called Dasupu.
Yes.
There they drilled an ice core at a record-breaking elevation. For one man, this core just might hold the answer to how the sun can influence our climate.
If you go and you succeed in recovering an ice core from the top of the Himalayas, 23,500 feet, in an area where no ice core has ever been recovered, you can be assured that you're going to find something new and exciting about how the Earth's climate works.
For expedition leader and glaciologist Lonnie Thompson, the greatest challenge was transporting these delicate cores, unmelted and unbroken, to a deep freeze in Ohio. Here at the Byrd Polar Research Center, 6,000 cores are kept at a constant minus 40 degrees. The oldest record dates back over 500,000 years. Earth's weather inscribes a detailed history in ice. Precipitation is recorded, as are volcanic eruptions and temperature swings. Thompson has to tease out which clues speak to the sun's impact on Earth's climate.
We're looking at a meter of ice core that comes from Sajama in Bolivia. This is from about 22,000 feet. The ice core represents a period of time of about 400 years ago. As you go down the core, you can see variations in light and dark ice, and these represent going from the wet season where you have the clear areas to the dry season where we have the dust layers. And we can put these together with the analysis in the lab and come up with a history of both the climate and the environment in this period of time for a part of the world where we have no records. So it's a frozen archive of our past.
By piecing together information from his global collection of cores, Thomson is seeking evidence of a historical pattern. A clear connection between the sun's cycles and the Earth's climate. In a laboratory far cleaner than an operating room, every inch of ice is studied. Pollen, ash, dust, even trapped bubbles of gas are all valuable clues to reconstructing our climate's past. The most intriguing find lies in the chemistry of the ice. After the cores are melted and tested, Thomson is able to chart a record of Earth's temperature. Results show a clear 11-year cycle in Earth's climate, a pattern in sync with the sunspot cycle. As it dims and brightens, our rhythmic sun seems to be leaving its mark on our globe. But a record from just one place on Earth isn't enough to prove a global pattern. So Thomson sets out on another journey, stumbling upon a site unlike any he had come across before. The first Westerner to trek this remote ice cap in Tibet, he discovered an unusual record of the sun's 11-year cycle, etched in visible terraces of snow. Here, even the subtlest shift in our sun has made a clear imprint on Earth.
If you stop the video, you can count those layers between those bands. Each of those layers is an annual dry season, spring, when the sand is moving on those sand dunes, you get the annual dust layer. And then every 11, 12 of those, you get the big, darker bands that you see on the cliff that are associated with activity on the sun.
No one had expected to see such a clear signature of the sun's cycle on our planet. One of the oldest ice core records discovered, the Tibetan terraces could yield a 500,000-year history of our sun. The deeper Thomson looks back in time, the more he'll learn about the sun's changeable nature.
Well, the sun is the most important thing that we have determining the Earth's climate. It was in the early days assumed that the sun was constant, but over the last 20 years, we know that it's not constant. There is a variation in the energy output of the sun. And so we need to understand how the sun has varied in the past, because that's part of understanding how the climate on the Earth works.
As he continues to unlock secrets in ice, Thomson is beginning to piece together what the sun holds in store for us. Given how little we know, it is wise to keep an eye on our sun, since for better or worse, we are tied to its cycles. And however much the sun has changed or will change, most life on Earth is bound to follow. Each morning, the sun rises to awaken the world, driving our planet, setting life into motion. In this uncertain universe, the one thing we can count on is that the sun will come up again. But can we be sure that it will be the same? We are just beginning to discover the dark side of the sun. One that blows off streams of hot, highly charged particles into space, the solar wind. Gusts traveling up to 1 million miles an hour can hit Earth within 2 days. An invisible magnetic field generated by the spinning dynamo of Earth's molten core shields us from this scalding wind. But what is the direct impact of the solar wind on Earth? Researchers at the University of California have designed a unique experiment to shed light on this important question. In this laboratory, Hafiz Rahman is trying to discover exactly how the solar wind affects our planet. Rahman has put together a model of our solar system. An accelerator will generate a blast of charged particles. A vacuum chamber will simulate the emptiness of space. And a small model of Earth, called a Torella, is the target. The Torella will be protected by a lab-generated magnetic field. Once the chamber is set and the vacuum ready, the accelerator will fire directly at the Torella. $150,000 amps will generate a wind of particles traveling faster than the speed of sound. Little is known about Earth's magnetic field. It is difficult to measure or define in space. Rahman now hopes to capture the field's reaction to a simulated solar wind.
Charging, 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 fire!
Science has given shape to an otherwise invisible event. The Torella's field is hammered by the wind, distorting and knocking it out of balance. And in the process, it creates an event we know as the aurora. Cranking up the wind speed a notch to simulate solar max, Rahman now hopes to see a change in the aurora. Sure enough, the polar lights brighten. Rahman has discovered that a faster solar wind creates a bigger aurora. This explains what aurora watchers have long known, that during solar max, the dancing lights are brighter and can be seen farther from the poles. Earth's magnetic field swarms with invisible charged particles. When the solar wind strikes the field, particles are kicked like cosmic pinballs down toward the poles. There they crash into our atmosphere to create bursts of auroral light. While scientists are just beginning to understand the power that brings the sky to life, those who live near the poles have long had their own interpretations. Myths of the aurora have been handed down through generations and are still cherished today. It is said that whistling can call up the lights, but children are also warned not to get too close, else they be swept away. Without the polar lights, this land would be dark for much of winter. For hunters traveling without help from the sun or moon, the lights could be beckoned to guide the way.
Oh! Oh! Oh no! Oh!
For shamans, the aurora offers spiritual guidance for a journey to commune with the dead. In this bone-cold land where the sun can vanish for months, nothing is more comforting than the shimmering spectacle of lights. On long winter nights, these Inuit of Hudson Bay recount their own particular tale of the aurora. They see the lights as the souls of their loved ones, playing a spectral game of soccer in the heavens. If you listen hard enough, you can hear the ghostly echoes of their running feet. If in some parts of the world people have a spiritual connection with the heavens, in other places, the sun seems irrelevant. Here in New York City, the cycle of day and night is only a faint pulse masked by rhythms of our own creation. People race around the clock, often too busy to even look up. With a virtual world at our fingertips, it's easy to overlook a higher power.
There are a number of things that we take for granted every day that can be affected by the sun.
Louis Lanzarotti is a space physicist at Bell Labs. He tracks advances in telecommunications and is keenly aware of the sun's potential.
It is ironical that as we've become more high-tech and we've become more wired, we have tended to forget nature. And in fact, here in New York City, if we go out at night, we don't see the stars in the Milky Way, and we're not enamored of the sky anymore because all the lights block the sky out. It's the same way with the sun. We don't recognize what the sun can do in terms of disturbances on the Earth. Even though we are so-called high-tech, we still forget that nature is a very important player in our everyday existence.
As we hurtle through a high-tech age, we're becoming more dependent on our sophisticated devices. But the very advances that seem to free us from the cycle of day and night also bind us to the sun in new and unexpected ways. When we approach solar max, the sun is more likely to blast Earth with high-energy particles. Our fast-growing networks, power cables, oil pipelines, and telephone wires all serve as giant lightning rods to catch the dangerous power of solar outbursts. At any moment, the sun could leave us in the dark.
Nature can always throw us a curveball, as we've known since we've monitored the sun rather closely for the last 150, 200 years. And so with a more wired world, we need to be very careful, and we need to be cautious, and we need to look at all the what-ifs to see if nature can get us or not, even if this is not a worse solar maximum than the last 2 or 3 that we've gone through, because several in the last have caused problems.
The solar max of 1989 was when we first began to realize just how devastating a solar blast can be. In March of that year, as the citizens of Quebec slept, no one knew that 93 million miles away, a menacing storm was brewing on the sun. A solar hurricane swept through space. 3 days later, it struck Earth, A magnetic storm quickly spread over the northern hemisphere, but the province of Quebec bore the brunt. Over 1 million amps overwhelmed the power grid. Power stations went down like dominoes, casting 7 million people into darkness. On the outskirts of Montreal, the Gombus family witnessed the blackout.
Well, I was sitting watching television. It was around maybe 2:30, and quick power surge just went off, and then it came back on, and then things just started getting dimmer. Like if everything had a dimmer switch to it, television, light bulbs, it just kept on getting dim, 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 and then it just stayed there. Looked at the light bulbs, the elements were glowing red hot, just the elements themselves, and even the house had a slight hum, like a light transformed. The whole house just had this general magnetic hum. I got this weird feeling, so I just looked outside and noticed everything just glowing. The color of snow was totally, usually it's white, you know, now it's like pink orange, what's going on? And I just came back inside and I went upstairs and I woke up my mom.
My son came and he shook me. He said, "Mother, get up. You will see something. Look outside, look outside." Then I go to the window. I open up, I lean myself out, and I see a bright, reddish, rusty light. It was beautiful but frightened at the same time. To myself, I couldn't figure what it could be.
I don't know, if it was a magnetic storm, it would have been more like a northern light sort of experience, you know, but this wasn't my personal experience. I don't think it was a magnetic storm. Could be visitors, I don't know, maybe not, maybe yes.
Well, at first I had a wrong opinion. I was thinking it's a spaceship. I thought it's a spaceship because that's why I was afraid to go out. I said I better stay in the house.
Next day, Hydro-Quebec announced that there was a magnetic storm in Quebec. Supposedly drained out all their power systems and was caused of the sun. And you know, it's different when somebody writes about it and when somebody sees it.
So I don't know how long I stood at the window, but I watched it really careful, what it was, because I know there's not something ordinary, something big.
The blast that knocked out Quebec's power was in fact a potent kind of solar storm that had been discovered only recently. In the 1960s, a team at the Naval Research Lab was perfecting a new instrument to look at a part of the sun only visible during eclipses. Usually not seen by the naked eye, the surrounding corona had long been an enigma. This blazing halo might bear witness to the sun's violent nature. The team figured out how to simulate eclipses, allowing them to view the corona on demand through a novel instrument called a coronagraph. Don Michaels was an astrophysicist on the project.
Basically, a coronagraph is just a small telescope. You point it right at the sun, but you don't want it to be blinded by the sun, so you make an artificial eclipse. You do that by taking a black disk and holding it out at arm's length in front of the telescope. So now the sun's blocked out, and you can see the corona around the sun.
To work well, instruments needed to be in space, above the veil of Earth's atmosphere. After World War II, solar science entered the space age at White Sands Missile Range. captured German V-2 rockets lofted instruments to record the sun, the first ever views from space. But getting the film back was another story.
And all they ever found was a big hole in the desert. Never found any pieces of the actual rocket, whether it buried or exploded or what. So the first lesson is don't let an object fall from 100 miles above the Earth, straight down, streamlined.
When Don Michaels joined the rocket team, he helped them with a key advance. A coronagraph was put into orbit. Images were then transmitted back to Earth to be reconstructed on black and white Polaroid film. The satellite soon delivered a dazzling surprise.
We saw pretty much what we expected to see for the first couple of months, until mid-December of that year. The technician who was pulling the film saw that there were some white spots on this particular picture, and looked at it and thought, as you would, well, I guess that was a bad piece of Polaroid film. But he ran the next picture, and there were still spots, but the spots had moved a little bit. And we did another picture, and the spots had moved more. And they were moving at an enormous speed, and they were enormously bright. And we had never seen anything like this before.
The team had stumbled on a solar storm of unbelievable proportions. No one had imagined that the sun could fire off such massive blasts of particles. What they had seen, now called a coronal mass ejection, or CME, made the scalding solar wind look like a gentle breeze. The discovery took the scientific world by storm. No one knew what these events might do to Earth, or how common they might be. To find out, a space station called Skylab was launched in 1973. The first manned orbiting laboratory, its instruments kept the sun under close watch. A clear picture of the sun's violent nature was beginning to take shape. The mission was recording on average 1 coronal mass ejection every other day. The discovery of CMEs was alarming. Space exploration was then in high gear. No one had suspected that astronauts on earlier missions could have been exposed to danger.
If you look back in old textbooks, you see that the Earth is there in space with the Earth's magnetic field extending outward into space forever. No hint that there's electrons and protons. No hint that there are high-energy particles from the sun. But when the first spacecraft were sent up, it was discovered that the space environment around the Earth is not benign at all. The August 1972 solar storm event was very, very severe. It was the most severe of that part of the solar cycle, and it's been one of the most severe of the last 2 or 3 solar cycles. And the high-energy radiations was such that the astronauts, if they had been en route to the moon at that time, could have had serious radiation sickness and perhaps could have been killed by that radiation. It was so intense.
At the dawn of a new millennium, construction of the International Space Station began during Solar Max. The mission will expose more astronauts to the sun's dangers than ever before. Braving frequent spacewalks, astronauts put their lives on the line. NASA has taken special precautions. The space station will have a heavily shielded room at its core where astronauts have a chance of riding out a solar storm. Astronauts may be at risk, but they will get warnings. Down on Earth, there is no place to hide. At the height of solar max, as many as 6 CMEs are discharged by the sun every day. Ground-based telescopes like Big Bear Solar Observatory are ever on the watch. Boasting one of the largest solar telescopes in the world, Big Bear is one of our best early warning systems, alerting us to the magnetic forces thought to trigger a solar blast. Detecting a coronal mass ejection aimed at Earth is difficult. An even greater challenge is predicting a CME. Researchers are learning to read the telltale signs of a coming eruption, from changes in the magnetic activity of sunspots. But from the ground, we can only watch the sun during daylight hours, and even then, only when not covered by clouds. To watch for solar danger around the clock, the place to be is space.
5, 4, 3, 2, 1, ignition, and liftoff of SOHO and the Atlas vehicle on an international mission of solar physics.
Launched in 1995, SOHO is the only spacecraft that can monitor our star 24 hours a day. A collaboration between the European Space Agency and NASA, SOHO views our sun in both visible and ultraviolet light.
Okay, so run this one until 1800. Then after 1800, switch to the limb.
As I understand it, the reason why
A stream of data and images is beamed down to the Goddard Space Flight Center in Maryland. Space weather has become a global concern.
Hvordan strålingsdosene på fly målt på Concorde og også ulike fly.
Pattern there is...
It's caused by the optics and trace?
Rainer, hast du den Flare schon gesehen?
The SOHO spacecraft is basically our eyes on the sun. It focuses constantly on the sun 24 hours a day, taking images. The reason that that's important for us is if you go away and you come back again, you've missed so much because things are happening all of the time. So it's very important that we keep looking at it constantly.
SOHO orbits at the point where the gravity of Earth and Sun are balanced.
And this is 1 million miles out. Now the sun's 93 million miles away, so it's not that much closer to the sun than we are. And that puts it outside of the influence of the Earth's magnetic field and everything else associated with the Earth. So we're getting a real clean, uninterrupted, 24-hour-a-day view of the sun. It makes movies. What we're seeing is things happen on the sun. We're seeing the activity, the dynamics. And I think that's the biggest breakthrough. That's the big, new, exciting thing about SOHO is that you're seeing the thing fly. And it's exciting. It's really exciting.
With a dozen sophisticated telescopes and instruments, SOHO serves two purposes. One is to probe the physics and structure of the sun. The other is to watch for signs of danger. How might the next huge solar blast play out? While we go about our lives unaware, a searing blast of particles could erupt off the sun into space.
Hey, Barb.
Yeah?
The first to see the event would be researchers at SOHO Mission Control.
It's a big one.
Yeah, it's a full 360-degree eruption. There's no doubt about that. Yeah, look
SOHO literally can't tell if the blast is coming or going, heading directly toward or away from Earth.
Going away.
Nearly 5 billion tons of solar matter races through space, dwarfing Mercury.
We've got a pretty good chunk going to the south and some east and some west here. So let's go look at the EIT data.
Great.
And see.
All right.
What you got?
It's really a big event on the front side. There's a big flare here, which triggered lots of activities here, and I think you can see something moving out from the sun.
At a speed of 1 million miles an hour, it reaches Venus 2.5 days after leaving the sun. Big Bear's instruments detect a magnetic disruption on the sun's face.
Okay, Big Bear saw it as well.
The SOHO team still doesn't know if the blast is coming toward Earth. They must wait to see if the spacecraft itself is struck.
Any idea how fast it's going yet?
There it is. We got a CME coming at us.
Definitely Earth-directed.
No uncertainty remains. The blast has hit SOHO and is on its way to Earth.
It's going to be less than an hour before it gets here. I should really call the polar teams and tell them. So you think you should put out an alert? Thanks.
Only a 1-hour warning goes out to defense, satellite operators, airlines, those tapped into the system. But most people would be completely unaware of the solar hurricane bearing down upon them. A communications satellite is hit. Although its orbit doesn't change, it's suddenly left outside the Earth's magnetic field. Spinning in place, it loses its bearings. All contact is lost. Without its protective shield, the satellite is now exposed to a direct hit from the blast. Killer electrons bombard vulnerable circuit boards, building up a dangerous charge. The satellite is literally fried. But the greatest impact might be felt on Earth. A solar burst could silence radio communications, leaving the military open to attack. Planes flying at high latitudes might be bombarded with radiation, exposing passengers to the equivalent of 100 chest X-rays. Pilots could lose radio contact with air traffic control. And with thousands of planes in the air at one time, the results could be deadly. With weather satellites out of commission, hurricanes wouldn't be seen coming. Our busiest cities might suffer the worst effects of the solar storm. ATMs could crash, pagers go silent, long-distance phone calls become impossible. And perhaps the ultimate nightmare comes to pass. Your cell phone goes dead. Today, we get only a 1-hour warning before a solar blast strikes Earth. Can we do better? An answer may lie in our own backyard.
Here, we have to fiddle with this box. And it goes to in there.
A boy playing with rockets may not be our solution to solar science, but not every kid has a rocket scientist for a mom.
5, 4, 3, 2, 1, 0, ignition!
Lika Guhatakorta is program scientist of one of NASA's most ambitious solar expeditions. Scheduled for launch in 2004, the Stereo mission will send twin spacecraft to view the sun from 2 different vantage points. It will take a 3D look at our star and help us measure the speed and direction of a CME.
Stereo, for the first time, will be sending 2 spacecraft that will veer away from the Sun-Earth line to get 2 different perspectives on the Sun. And what that's going to give us is a stereoscopic 3-dimensional view of this stellar object for the very first time. And we'll see what truly are the shapes and sizes of these massive ejections that we see from the Sun.
Among the space relics in a NASA museum, Lika and her son play out the future mission.
For instance, Tristan, my son, represents the sun of our solar system, and the balloon he is blowing is a coronal mass ejection pointed in the Earth direction. I represent one of the stereo spacecraft, which is in the leading orbit, and this spacecraft is going to view the coronal mass ejection from this angle. Let's go to the second position. This is the second position of another stereo spacecraft, and we are going to view the coronal mass ejections from this angle. Scientists are going to combine these 2 views and actually produce a 3-dimensional image of the coronal mass ejection coming towards Earth for the very first time. And it's going to allow us to determine the speed of the coronal mass ejection, its magnetic field geometry, and its composition.
A CME builds on the face of the sun. Stereo sees it's headed right for us.
3, 2, 1.
Traveling at over 1 million miles an hour, it aims for a head-on collision with Earth.
Tristan.
As this mom well knows, the sun can sometimes be naughty. The cold, dark vastness of space is warmed and illuminated by stars. Some may be better behaved than our sun, others more unruly. But our planet's fate is bound to our daytime star, for better or worse. We literally live inside the extended atmosphere of our sun. So we must continue to study its moods.
The sun is a star we live with, and in this technologically driven society, if we really don't understand the sun-Earth connection, I think we are at a loss.
What we should be doing is to anticipate as much as we can potential effects. Then we should try to learn as much as we can about the sun during this solar maximum and the Earth-space environment so we can plan for the next one.
This solar maximum is really very exciting for us. We've got the most spectacular observatory in space that we've ever had. And we have lots of observatories on the ground. We're going to be able to look at it this time and see what's going on in much better ways than we've ever been able to before.
I don't think scientists really fully understand yet the true nature of the sun. It's one of those that the deeper you look, the more questions you come up with. And it's almost like this mystery. The deeper you probe, the more confusing and the more mysterious it becomes.
The sun will continue to nourish our planet, rising, setting, drenching our land in light and warmth. But our star, the only star whose face we see, is temperamental. We are beginning to discover its real nature. The Inuit have long known their lives were bound to the sun. They embrace and celebrate their connection to the heavens. Could they know something we have long forgotten or tried to deny? our lives dance to the rhythm of the sun. As we continue to explore our ever-changing star, we may start to see it in its true light.